When solving any quadratic equations, because there are often unlike terms involved, we need to look to get the equation equal to 0 and express one side of the equation in factored form. So we'll need to remove the 12p and the take p squared here and move it across to the left-hand side. When we do that, we get 2p squared minus 7p minus 15 all equal to 0. To factorise a quadratic expression where the squared term, in this case p squared, has a coefficient not equal to 1, we need to do something a little bit extra. We could look for a common factor of 2 first and take that out the front of the whole expression, but that's not going to work because it's not common. The next thing we need to do is break it up into two brackets, and there's a variety of ways of doing this. Let's go through one possibility to factorise an expression into two brackets, where we look at the 2p squared term first, or the squared term, and we look at what multiplies to that. It must be a p and a p, and because 2 is a prime number, 2 multiplied by 1 will give us 2. So 2p in one bracket, p in the other. Now we need to ask ourselves what multiplies to the n term, or the constant. We'll worry about the negatives later, but a common product for 15 is 5 and 3. Let's look what happens when we multiply out the brackets in the second last line. 2p by p is 2p squared, 2p by 3 is 6p, 5 by p is 5p, and 5 3s are 15. But we can see with the 6p and 5p, there's no way that we can make that negative 7p. And they're the only p terms, so that means we're restricted here, and that factorisation is not correct. Let's have a look at another option where we've got perhaps a 3 and the 5 switched around. They still multiply to 15, and again we'll worry about the negatives later. Let's see what happens when we multiply out these brackets. 2p multiplied by p gives us 2p squared, 2p by 5 gives us 10p, 3 multiplied by p gives us 3p, and 3 5s are 15. And we can make 10p and 3p come to 7. We'll have a look at the negatives now and see how we make it work. If we put a positive where the 3 is and a negative where the 5 is, they multiply to give us negative 15, and we multiply the 2p and the negative 5 to give us negative 10p, and negative 10p and positive 3p will add to make negative 7p. There's a fair bit of trial and error there, but with practice you do get better at factorising these types of quadratic trinomials. Let's have a look then, once we've got those two brackets, what the solutions could be. Either 2p plus 3 equals 0, that's the first bracket, in which case we can remove the 3 and then the 2, and we get p is equal to negative 1.5. The other possibility is that the second bracket, p take 5 equals 0, and we can find out what p is by taking 5 across to the other side, and we get in this case that p equals 5. So our two solutions for the initial quadratic equation are that p is equal to negative 1.5 or p is equal to 5.